This is a demonstration of overhead wiring design program. A sample overhead wire would be placed over one span only, with anchor spans on either side. Essentially, we would start our wire at this point here, which is going to be an anchor point. We'll go nearly to the center line of the stack here, come over the center line again, and anchor out to this particular anchor here. The program comes with extensive on-screen help menus, boxes, option boxes, and input boxes depending upon where you are. In the present case, it is asking me if I have selected the level and symbology of overhead wire. We have chosen red colored wire, which is out of running, which is shown as dashed wire. Now it is asking me the starting point of overhead wiring span, and it has lots of options to choose from depending upon what designer wants in what situation you are. The first thing I'm interested is to zoom in the area of my interest, which happens to be this area here. It again as I said, this would throw a lot of option boxes, information boxes. We'll just go into this window area here, and we would go near this area here. Now, after having selected the starting point of overhead wire span, we need to give it a ending point of overhead wire span. We again have plenty of choices, and depending upon where you stand and what your requirements are, you have to select one of them. In the present case, we would select this particular option. We would give here an option of -250 here. Now, as you can see here, it has drawn the overhead wiring here. It has shown a bit of distance here. Of course, they are in the same color as set of wire, and it has shown a stagger value here, which is to the right side of the track center line, looking back to Sydney. Incidentally, this is the Sydney side, and this is the countryside. So the convention is Sydney is always on the left or on the bottom side. Normally, we'll keep it on the left side. And as I before said, these values and these values are in red, which is the color of the wire chosen. It asks me further question here, which depends upon the center line of the track and structure number. We'll keep here a bit of leverage here. We'll make it 25 here and really see what it has done. You can see here some sort of this circles have come in here, which we will zoom out and see them in a couple of minutes time. But so far our design is quite okay, and we would like to continue. Is the starting point an angle? Yes, it is. Would you like to place angle of deviation? Yes. Now, as you can see, it has placed this angle of deviation, and it has placed the anchors now. and it is asking us to proceed ahead. So this distance comes in, anchors come in, deviation comes in, stagger comes in, and all of them are quite automated, as you can see. Now what we need to do is now to proceed ahead and go ahead with this. We will make this in running wire now, and as you can see, this value, this thing dashes are going to become solid after I press OK. Now let's go back and do a bit of view operations. We choose again intersection of structure and track and stagger. Now again something has happened now. Number one is a stagger has been placed here. Of course the wire has been placed in red. A distance has been placed. A line has been placed, which is what it is asking me. Please pick up intersection of track center line and new line. So we click on this new line, the track center, and it gives me a bit of two values which we will discuss in a short while. It asks some more questions, and it has given me now a bit of blowout values, or the maximum blowout values. Because there are two curves, it says to me one blowout has maximum value on or near ends of near to end, and the second blowout has a maximum value of 482, which it has promptly put in here, which we'll again zoom in to see what it is. It again asks you some questions here, and it says design okay, yes. Would I like to continue with more design? Yes. Now we would zoom in at this time to see what has happened. First of all, we will zoom in here. It has placed a couple of curves here. You can see the red curve on the top line and the bottom line, which are the blowout curves. It has found that at this point, this bottom curve has a stagger of 482. Even though this is not acceptable, but for demonstration purposes, I would accept this as okay. It has a over sign of 0. It has a mid-bay stagger as 250. It has put in load factors here, and it has of course put in those stagger values here, which we have shown. We will also show some of these coding cells, which are essentially represent like how the wire is going to be strung at this point. Likewise, it has placed another coding cells here, which will again show how are we going to put this wires here. I mean, what are the physical arrangement what we'll be doing. Now at this point, we would just like to anchor our points at this step and finish the design. We will again change this particular thing to out of running wire. We'll say out of running, and as you can see, this thing turning dashed again. We'll choose the end point of previous overhead wiring and physical point as the end point. Let's again put some values of distance, a bit of load factors, and we say design is okay. and I would not like to continue to do more design. Yes, this is true, and this is true as well. Now, now it has essentially put in these values of this angle of deviation, which is used by a civil design group to find the loadings on your structures. We would like anchors to be placed, and with this one the design is complete. We would just pan through this design as to how it looks like. So we have got an anchor here, bit of distance here, bit of angle of deviations, anchors, representative overhead wire which is out of running, bit of load factors, bit of more values of required in design, and we'll just take a bit of overall picture of how this whole three-span thing look like. These particular coding, what we call as coding eggs, are slot holders for some text to be placed in. So we can, for example, say +1 RDT star, and which will be filled up here, which essentially represents what sort of thing they look like when it is. Likewise, we can fill up here. We'll say A is equal to 6.50, or it is downshore for that matter.